Welcome back to All This Math. This is Professor Parker. Please make sure you are subscribed to the All This Math channel. Make sure you like this video. Make sure you drop a comment below. Make sure you share this video with at least one other person. All right, so what we got here? Okay, today we are finding the LCM, also known as the least common multiple. That's what we're about to do. About to find the LCM, or the least common multiple. Very important concept. Now, let's make sure we don't confuse a multiple with a factor. We need to know the difference between multiples and factors. Let's take a number, for example. Let's take the number 12. All right, the number 12. The number 12 has many factors. It has 1, 12 itself, 3, 4, 6, and 2, right? Those are numbers that can be multiplied to make 12. Those numbers are called factors. Those are factors, like contributing factors to a situation or a circumstance, right? Those numbers are called factors. The number 12 in that scenario is the multiple, right? So let understand the difference and the distinction between multiples and factors. Factors are the numbers you multiply together to make the multiple. Factors are the numbers you multiply together to make the multiple. They're not the same thing, right? And don't confuse them, right? So when we're looking for greatest common factors, make sure you find the greatest common factor. When we're looking for a least common multiple, make sure you find the least common multiple though. All right. So look, I got two examples up here. All right. So what I'm going to do is I'm not going to just eyeball these. I'm going to use what we call the Lumumba method, or what I call the Lumumba method, right? Because I want people to know about some little bit of African history at the same time while they're learning math. So, and make sure you understand and know, go do your research on Patrice Lumumba, Lumumba, Patrice Lumumba. All right, from out of the Congo, in the central part of the continent of Africa. All right, so 6, 8, and 10. We're gonna do this one first. So number one, matter of fact, let's do this. Boom. We're gonna write the numbers over again. We're gonna write 6, then 8, then 10. And then we're gonna draw an L, like an upside down long division symbol. Upside down long division symbol. Now, what we're about to do is we're gonna look for common factors, right? Common factors, or a common factor, right? That's what we're looking for, common factor. So what would be a common factor of 6, 8, and 10? Now, when we do this method, if we're trying to compare three numbers and find an LCM, we don't have to find a common factor. We don't always have to find a common factor that's common to all three. We really only need to find a common factor to a minimum of 2. But in this particular instance, it just so happens that the common factor of 6, 8, and 10 would be 2 anyway. They share a common factor. So you find the common factor of at least 2 of the numbers, at least 2. Here we find the common factor of all 3, right? But at least 2 is the protocol. All right. Then we're going to divide by the common factor. So we're going to do 6 divided by 2, which is 3. Make sure you know your division facts. So you know that 6 divided by 2 is 3 off the top of your head. Make sure you don't need a calculator for that. You should not need a calculator to know that 6 divided by 2 equals 3. All right. If you're a little young, I'll give you a pass. But you know what I'm saying? If you're older, middle school age, high school, beyond, you should not need a calculator for that. Then we do 8 divided by 2. Again, mental math. You should have that memorized. Division facts. 8 divided by 2 is 4. So you write the 4 right there under the 8. Then we do 10 divided by 2. So what we're doing, you divide each of these numbers by the common factor. Divide each of these numbers by the common factor. 10 divided by 2 is 5. Put the 5 underneath for the 10. Now, these three numbers are what we call relatively prime. Relatively prime. Now, what that means is that they have a common factor of 1. Anytime you have a group of numbers and their common factor is 1, that means those numbers are what we call relatively prime, meaning relative to each other. Compared to each other, they're prime. Now, they're relatively prime because while 3 is a prime number, it only has 2 factors, 3 and 1. That's the definition of a prime number. What's the definition of a prime number? Numbers that only have 2 factors, 1 and they self, right? 5 is a prime number. It's only got 2 factors, 5 and 1. 1 and itself. 4 is not a prime number, though. 4 don't got a whole bunch of factors, but 4 is still composite. 4 has more than 2 factors. Composite numbers have more than 2 factors. Prime numbers only got 2 factors. The number 1 is an anomaly. 1 only has 1 factor. It's in a class all by itself. It's not prime. It's not definitely not composite. But 4 has the factors 4, 1, and 2 as well. So 4 has 3 factors. All right, but these are relatively prime. These 3 are relatively prime. Once you get to the situation where the numbers are relatively prime, then you do this. And this is part of the reason that I call this the Lumumba method. You draw another L, like a box L, like such. And then you're going to multiply these four numbers together, or however many numbers it is. You're going to multiply them together. When you multiply them together, you do 2 times 3, which is 6. 6 times 4 is 24. 24 times 5 is 24 times 5. 20, well, let's break the 24 down into 20 and 4. 20 and 4. 20 times 5 is 100. 4 times 5 is 20. Put the 100 with the 20, that's 120. So that's going to be 120. That's the LCM. So the LCM of 6, 8, and 10 is 120. Is that true? Hold up. Make sure this is correct. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. 10 times 5 is 50. 10 times 6 is 60. 10 times 7 is 70. 10 times 8 is 80. 10 times 9 is 90. 10 times 10 is 100. 10 times 11, 110. 10 times 12. Yeah, you're right. Yeah, it is 120. I didn't know you had to go that far, because think about this conceptually as a concept, right? What is an LCM? An LCM is like a meeting point. It's a meetup, right? Where we going to meet at? Like, you and your friends got to decide where we going to meet up at. We linking up or whatever. Where we going to link up at, though, right? The LCM is like a meeting point for these three numbers, 6, 8, and 10. All right. And it's the closest place, right? That's convenient and logistically sound for all of us, right? For 6, 8, and 10. 120 is that number. 120 is that location. All right. They can't meet up at, like, 6 can go to 36, because 6 times 6 is 36. But 36 is not a convenient meeting place for 8 or 10, because 36 is not a multiple of 8, and it's definitely not a multiple of 10. 10 can go to 100. 10 can link up at 100, but 100 is not convenient for 6, because 100 is not a multiple of 6. 100 is not a multiple of 8, right? Know your multiplication facts, so this will all make sense to you. 8 times 8 is 64. 64 is cool for 8, but 64 ain't cool for 6. 64 ain't cool for 10. How about this? What about, let me see. What about 24? 24 is cool for 6. 6 is like, cool, I'll meet you at 24. 8 is like, cool, I'll meet you at 24. We can meet at 24. What about 10? 10 can't go to 24, because 24 is not a multiple of 10. All right. So understand what an LCM is as a concept. All right. Concept is key. All right. It's nice. It's all cool and all good to know the process, but make sure you understand the concept. If you understand the concept, when you see questions like this on a standardized test, you know, a PSSA, a Keystone exam, if you live in Pennsylvania, you know what I'm saying, in Philly or wherever, or an MCAP exam if you're down in Baltimore, right? You'll understand what they're talking, especially on the open-ended questions, the constructive response questions at the end that a lot of kids just be folding on. Don't even try to answer them. Don't even try to read them. If you know the concept of an LCM, those questions get a lot easier, I promise you. All right, let's look at number 2. Number 2, we got 3 bigger numbers. All right, these numbers are bigger, 12, 15, and 20. So we're going to write the numbers over, 12, 15, 20. Right? We do our upside down L. Well, it's an upside down long division sign, but it's our L for Lumumba. L for Lumumba, right? So we want a common factor of 12, at least 2 of those numbers. At least 2 of those numbers. So dig this, right? 12 and 15 have a common factor of 3. 15 and 20 have a common factor of 5. 12 and 20 have a common factor of, well, a couple common factors of 4, also of 2, right? But the point is that all 3 of these numbers do not share a common factor besides 1. All right. Because of that, we can take a common factor of 2 of these. Let's say I take a common factor of 12 and 15, which will be 3, right? The common factor of 12 and 15 is going to be 3. Because I could do 3 times 4 to get 12. I could do 3 times 5 to get 15. So I take that 3. Where do I write it? I take that 3 and I write him right here, right? And then my job is to do division. Then I'm going to do 12 divided by 3. That's going to give me 4. So I write the 4 right there. And then I do 15 divided by 3. It's going to give me 5. Write the 5 right there, right? So look. Now, oh, what about this? What about here? Can I do 20 divided by 3? Well, I could, but that would not give me a whole number for my quotient. So when that happens, I just bring the number down. Just bring the 20 down. All right. So if that, again, that's a rule for you to write down in your notes. if you're using this method, right, online it's called the ladder method, but I call it the Lumumba method. If you're using this method, if there's one of the numbers that's not divisible by the factor you wrote, then you just rewrite that number. Just rewrite that number. That's all you do. Just bring that down. All right. So now we're doing it again. We got 4, 5, and 20. So what I'm going to do? All right. I'm going to do this. I know 5 and 20 have a common factor of 5, right? Because 5 times 1 is 5. 5 times 4 is 20. 4 and 20 have a common factor. Let's do this. Let's mess with the 4 and the 20. Let's do the 4 and the 20. One of the reasons I like math so much is because with math, we have options, and I like to have options. All right. So 4 and 20, right? So what's the common factor between 4 and 20? Is 4. Well, it's one of the common factors because 2 is also a common factor between 4 and 20, right? So we got 4 and 20. So now I'm doing division. I'm doing 4 divided by 4. That's 1. Write that down there. 5 divided by 4. Now, 4 is not a factor of 5. 4 is not a factor of 5. So when that happens, you just drop the number down. Just bring him down, right? And then we do 20 divided by 4. 20 divided by 4. 4 is a factor of 20. And now we got 5. So now we're going to do this again. We're going to do this again, all right? Because the 5 and the 5 have a common factor. So we're going to do this step, I think, one more time. One more time. The common factor between 5 and 5 is 5, right? So we're going to write the 5 out here. And then 5 is not a factor of 1. It is not a factor of 1. So what you do in that situation, just bring the number down, all right? 5 divided by 5 gives you 1. Right there, right there. 5 divided by 5 gives you 1 again. Now we got 3 ones. We can't do nothing with 3 ones, right? So these numbers are, well, even though 1 is not a prime number, technically, we would consider these 3 numbers relatively prime, I believe. All right. We would consider them that. We would treat them that way. All right. So now what we're going to do is this. We're going to draw a block L. I mean, this part you don't got to do. This is just what I like to do. You know what I mean? You could just multiply the numbers already. You know? And you go down like that. Then I'm going to slide over like this. And now I got a big L, right? So I got 3 times 4 is 12. And then I multiply these digits or multiply these numbers. 3 times 4 gives you 12. 12 times 5 gives you 60. 60 times 1 times 1 times 1 is just 60. So that means that the least common multiple of these 3 numbers is 60. That's the meeting point. That's where they're going to meet up at. So 12 can meet up at 60 because 12 times 5 is 60. 15 can meet up at 60 because 15 times 4 is 60. 20 can meet up at 60 because 20 times 3 is 60. And 60 is the closest place where they can meet up at that makes sense, right? It's the closest place that makes sense for them to meet up at. All right. So that will be 60. All right. What else did I want to say? Let me see. 20 times 2 is 40. Yeah. That's about it. So yeah, this is the Lumumba method for finding the least common multiple. All right. And you can do this with any numbers, just play around. You know what I'm saying? Get some practice because practice is key. All right. Stay locked in. See you on the next video.